Good morning all. Today some soldering, and I'm going to be making up the Pong sync generator board. Just one of them, I don't need all five. So I think I'm going to start with the resistors. So on the schematics, really weird this printer. This is one of these eco tank printers where you get tons and tons of ink. It just rarely prints colour accurately or without missing stripes, unless I leave it for about 6 months and print only black and white. And then when I come back to printing colour, it's absolutely perfect. There's not a mark on that. Anyway, components I need: 100K, 12K, 22K, 1K, 8. Oh, look at that. All the values I need. So I only need one of each of these values. Oh, there's 100K. 22K. Now you may notice this iron looks slightly different to normal, and that's because I've updated the firmware on it. I've put the RALIM firmware on it, RALIM. Now when I first got this iron, everyone said, oh, put the RALIM firmware on it, put the new firmware on it, it's much better, put the firmware on it. And I resisted because nobody actually said why it was better. And I thought, well, until I know why it's better, there's no point putting it on. It might be worse. You know, everyone's opinion's different. But recently, I've been winding the temperature up on this thing in order to solder these things. Yes, the ground point. So there's one in the middle of the shot there. And you can see that that pad is spoked out onto the ground plane. There are a couple there on the right hand side of those two capacitors and on the corner of the chip. And the trouble with that is that, well, I keep the clearance between my tracks and the ground plane quite small so that I don't get breaks in the ground plane in a little gap like that. But the trouble is that means that the spokes are very short and fat, and when you try to solder that, the heat just vanishes into the ground plane, and it's much harder to solder those ground points. So I had been manually raising the temperature of this iron up, but the problem with that is that you press and hold one of these buttons. Yeah, the sort of operating temperature would wind up, then it would take several seconds for it to time out of that screen, and only then would it go, oh, you want the temperature up, do you? And actually wind it up. So it could take about 10 seconds for it to respond and put the temperature up. And then, of course, I immediately wanted it to drop back down again for soldering other pads, standard pads. Well, the firmware in here has a boost mode. So when this is in its on mode, which I can do, I can switch it on now. So it looks totally different. It's got the temperature in bigger numbers there, a little battery icon, and I've set this to 5S because I typically run this off power tool batteries, which are 5 cells. So it's saying that the battery is almost full. So I've set my operating set point to 350, but if I want to do a boost now, I simply hold the front button, the arrow comes on, I boost it up and it will limit at 420. But you can actually let go at any temperature. It just boosts for a short period of time, and now you can see it's just immediately falling back down to my set point, which is 350. So if you want that boost feature, and I particularly do want it for these ground pads, these grounded pads, then this RALIM firmware is extremely useful. So press and hold that, boost it up, and if I keep holding that, it will boost up to my boost set point, which is 420. And then the minute I let go, and you can let go before you make the solder joint because this is now hot. There's a lot of thermal energy in there which can get transferred to the pad, and you can make a successful joint, and then this falls back to the normal temperature. That's so much better. So I have a justification for putting this firmware on, so I've put it on. And this is quite fun. Look, it goes zzz when it goes into sleep mode, and you can see the temperature winding down. And if I move that, the accelerometer should immediately push that back up to my operating temperature of 350 degrees. Right, let's start putting some components in. So referring to this, R300, R422, let's do those. 100k, let's bend that. 22k, that's that one. Got to be careful because it looks a little bit like 12k, but that's definitely 22k. Now, I did say in the previous video, actually I don't think I actually said it verbally, I think I put it in the description. If there are any questions, then put them in the comments and I'll gladly answer them in the next video. The only one I can actually see that's a question as such is, what make and model of soldering iron do you use? Well, it's the TS100. I can't remember the manufacturer now. It's got some strange name like Mini Me or something. But it's the TS100 soldering iron, and I put the Ralim firmware on it. Right, some actual soldering. Let's get this one in. Going for my minimum solder idea. There were some comments about that. Some people saying, no, you absolutely must have a concave mound. But I'm not sure that's the case. That's fine for single-sided, because on a single-sided board you're interfacing a stick with a flat plane, and therefore you need a mound on there. But here you're interfacing a stick with a cylinder, and a 1.6mm long cylinder. Quite a long cylinder. Masses of surface area joining the one to the other. So as long as solder enters there and fills it reasonably well, that is a huge amount of surface area. Where are my cutters? So this is two free-running astable oscillators, one at field frequency, which is 50 Hz, the other one at line frequency, which is 15.625 kilohertz. You want to see the screen on that soldering iron, don't you? The capacitors here, I think, are 100N, and then something much smaller, 2N2, I think, goes in there. And obviously the pot here gives you control over those frequencies to sync the CRT monitor into these two sync signals. My filling idea works better if I bring the soldering iron in from the side where the wire is pushed against the outside of the hole. Doesn't seem to work quite so well if I do it on the side where there's a gap. I have no idea why. Some mechanical issue, no doubt. If I think about it for long enough, I can probably work it out. In fact, let's set the sleep timer to 2 minutes. So press and hold back for off. Now I've set the more detailed cooldown screen, but I think I might go back to the standard cooldown screen actually, because I'm not sure there's enough detail in there to make it worthwhile. It says tip, and that's cooling down. It's about 310. Set point 350, and input V 19.2. That could have been much shorter, and you could have had a fourth piece of information in there. Okay, so I think back button is settings. So the power source 5S, soldering settings. I want sleep modes. Let's go into that. Sleep temp. I can't remember how you do this. Oh yeah, sleep timeout 1 minute. So we'll go to 2 minutes. That's good. Shutdown timeout 10 minutes. That's probably okay. Motion sensitivity 7. Sleep modes. User interface. And I've got a feeling it's in advanced. Detailed idle screen, yes, I don't want that. So let's go through the rest of that. Detailed solder screen, factory reset, tip, model, calibrate temperature, calibrate input voltage, advanced options, and back to the... So this is the standard cooldown screen. And what I like about this, and the older firmware didn't do this, although you could get it, when it was cooling down, the old firmware just showed a sort of stylized image of the whole iron. Yes, this also does the right and left-handed thing using the accelerometer. This one shows you the temperature of the iron as it cools down, and I'd much rather have that on the screen so that I know when it's cooling down whether it's actually cool or not. Good, so that's my settings changed. It's got 2 minutes sleep timer now. Right, there's a bunch of 330 ohm resistors here, 8, 9 and 11, all 330 ohms. Let's get some of them. Interesting, that's not a value that's used in the vocoder, so I don't have 330, so I'll use one of these empty boxes. I should have some 330s somewhere, and make up a new box, and I'll insert it here between these two. Got some stickers here, sort of pre-cut to these small shapes, so 330R. This ink takes a while to dry. Yeah, there's plenty of 330 ohm resistors in these packs that came from Rapid Electronics. Don't think they sell these anymore. You can buy the individual resistors in packs of 100 though, but I quite like this starter pack. It was quite good, it had lots of good values. So 33 black, 330, and no more zeros. Cut these into twos, put them in my little box. Drop these in here. Now I wanted 3, didn't I? So I'll leave 4 out for my circuit. Those are done. That sticker, hopefully, I don't think it's quite dry yet, that ink. So resistors 8, 9 and 11, and all 3 of these go to ground, so I can use the boost mode on the iron to boost that temperature up. Despite these things being temperature controlled, that's gone to sleep a bit, 48 degrees. They just don't have enough thermal mass to hold enough thermal energy to make these grounded joints. So the only solution is to just take the temperature way above what you actually need. A lot of that energy then gets thrown into the ground plane around the pad, and there's enough left in the iron to actually make the joint. So it kind of defeats the purpose of a temperature controlled iron really, but temperature controlled is one thing. Its power, its ability to replenish that heat just isn't there. I can't remember what these were again. 8, 9 and 11. Oh, 11's up there. Okay. Right, this has gone into full timeout, so I need to restart that. Take that back up to 350. So I'll do the 3 non-grounded joints first, which, when this comes up to temperature, that's pretty close. Is that a non-grounded? Why isn't that one grounded? Have I put that? Oh no, that's 2 pins from 2 different resistors. So these are non-grounded, so these can be done at 350. And not that one, this one here is not grounded. Okay, so to boost, I just press and hold this front button. Wait till it gets up to that higher temperature, and then I can solder, because my tip now has much more energy in it, I can solder these ground spoked ones. That needs to go up again because that took the whole lot of energy out. Looks like you might have to do it for each one. Yeah, that's almost down to 350 again, isn't it? Still, it's a lot more convenient with this than it was on the old firmware. And it's still slightly tricky to get it to fill those ground spoked holes, but certainly easier than it was. Right, finally, I think the ink's dry on here, 330 ohms. Oh, I've dropped it on the table. There's my knife. There it is. And that can be added into my low value resistors between 430 and 150. There we are. Right, a whole bunch of diodes, 1N4 and 4/8. There's one up there, and then there are 8 here, which are it's like a wired OR input for all the video signals. So if any one of them is high, it pulls the video line high with an OR function. Let's put the first of these diodes in. Oh, that's very shallow. Fill that a little bit more. And this one is a ground one, so I'll go boost. Press and hold that up to 400-ish and solder it. Yeah, that works really well. And then by the time you finish soldering, that's pretty much back down to normal temperature. Snip that one. Oh, I think these might be steel legs. Where's Porky? No, Spiky. Yes, that wasn't a very good idea, was it? Because all my diodes have leapt up onto that magnet. Spiky can go there. Yeah, I decided not against Porky because I don't think we really have porcupines in this country. We have hedgehogs. Definitely fighting a losing battle with the magnet and diodes thing. Okay, let's put 4 of these diodes in. And then I'll do the other 4. Good. Right, the diodes are all in this diode array here. They look pretty nice. And there's a diode up there. So now I need a couple of caps here. I think one's 100 mic and one's 50 mic. And the 2 oscillator timing capacitors, C1 and C2. So I bought one of these electrolytic kits. There's 47. I think that's one of the values. And the other one is 100. Yeah, there's the 47 mic and there's the 100 microfarads. And I think this time I even used symbols which have a plus and a negative marked on there. Oh yes, I remember a comment from the previous video. Where's the blue tack? Well, here's some blue tack. And I'm going to use it to hold in my 47 microfarad while I solder that. Let's do that. Oh, that's gone into zzz again. I wonder if 2 minutes is a bit short. Perhaps it is. Although generally you're not hunting around for components between solder joints. Okay, this one doesn't appear to have a grounding point. But now, of course, the board won't lie flat and it's wobbling around all over the place. Time to balance the board on one of these plastic trays now, since it won't lie flat on the table, on the mat. Solder this one in. And I think we're now getting close. Oh no, I need my 2 timing capacitors, don't I? These are steel legs. Cheap capacitors bought on eBay. So I've done these as 0.1 inch pitch, and I've got the 100N in 0.1 inch, but the 2N2 I think I've only got, let's have a look, yeah, 222 in that one. I've only got in 2/10 pitch, so that one's going to have to be bent a little bit. Yes, that's really most unsatisfactory, isn't it? Having that capacitor sat up on those legs, which had to be bent to fit the footprint on the board. Right, after not too extensive searching, I found a 556 and the LS00. So I'm now going to make up my little pin arrays. They're going to be in 7s, aren't they? Yeah, 7 and another 7. 4 left, so these must be in 32 pin strips. 4 7s are 28, 32. Right, U1 is the 556, holding it in with my little finger, holding the board with thumb and ring finger, and solder with forefinger and middle finger. Should be fine. Let's, oh, bit of solder on that. Let's just bring a couple of pins in. That didn't quite take, because it's a bit tricky doing a 5-finger hold. I think I've managed the corners. Okay, so now I'll push that chip down onto some blue tack. So it sits there without wobbling about, and solder the other pins. The chip's in the socket, it won't mind the heat, and it does help to keep the pins orderly and lined up. That looks like power. And that one looks like it's spoked, so I'll just do a boost. In fact, I should hold that really, shouldn't I? And solder it while I'm holding that button. I think that's how it's meant to be used. So you'll notice the odd alignment of one chip with respect to the other, and I had them both in the same orientation initially, and it just wasn't working from the point of view of wiring it up. So I turned this one around 90 degrees and it kind of just fell into place. Sometimes it just works out like that. So I'll just finish soldering in this LSOO, including a spoked ground pin. I'll do that now. Hold that, let it go up to 400-ish. Do that ground pin, and then I can carry on. Let the temperature fall back. And that's the chip complete. So the remainder of this board are the 2-pin JSTs, which I believe I've got somewhere. More of these turned pin arrays for the video inputs, the sync, field and line. I should have marked those actually, shouldn't I? But anyway, the line and field sync outputs, again on 5-pin turned pin arrays. And the 2 pots, and I know one of them I don't have. I think I've got a 10k LIN. Don't think I've got a 250k LIN. So I'll carry on and do as much of this as I can. Just caught the eye with the back of my finger as I was bringing something from over there, but I don't think it's caused too much trouble. Right, let's get these 5-pin arrays in here. Well, that's pretty much finished. All bar the 2 pots, and although I probably have one of the pots, I don't think I have the other one, so I'll have to put an order in for that. So unfortunately I can't attach this to the front panel. I suppose I could put trimmer pots in and just temporarily tack them on. I've got a feeling, yeah, so the wiper is attached to the positive, I think, at one end. So it's only in fact a 2-terminal variable resistor. But essentially that's it. So I think that's another Soldering with Julian session over. Thanks for joining me, and I'll see you again in the next one. Cheerio.